Okay, so the plan is this is 4.5, but I'm going to go over a little bit of 4.4 from yesterday because a lot of you guys weren't here. Basically, we talked about boots and hats, trees have roots, the nook, whatever you guys need to do. The biggest thing is any number, x to the power of a fraction, m over n, this turns into a root of x. It is a m, or the nth root of x, and the whole thing is to the power of m. This can be written like this, or it can be written like this. Exact same thing. Doesn't really matter which way you do it. I will zoom in one tick for you guys. How's that? Okay. We then went over roughly how to break these down and your steps for doing so. So if we had a number like 36 to the power of 3 over 2, your step 1 is to always write it as a root. Okay, so in this case here, it'd be some root of 36. Our n is 2, so it'd be the square root of 36 cubed. Whenever you're solving these, it's always good to solve the root first and then cube it at the end. You could cube it first and then take the root, but usually the math isn't very nice for it.
What if it was 36 and just 3?
What do you mean?
36 to the power of 3.
It'd just be 36 to the power of 3. You'd write 36 to the power of 3. So the square root of 36 should be 6, and 6 cubed should be, what, 216? And that's how we solve these. We gave you guys a couple more tricky ones. One thing we did not go over yesterday was how to go in reverse. So if we had a root, something like the square root of 52 cubed, could you go in reverse and write it as an exponent? Where basically we say, okay, we got 52. We know this is a square root, so it's over 2, and it's to the power of 3 over 2. You're just going in reverse. Same thing, nothing else has really changed. One thing to note is if you can reduce your fraction, you do get the same answer. So, if I had the fourth root of 68 to the power of 2, this isn't the same ideology or the same reason that if you have a square root and x squared, it cancels off and gives you x. If you wrote this out as an exponent, we'd have 68 to the power of 2 over 4. If you reduce that fraction down, it'd be 68 to the power of 1/2. If you took the exponent root for this, if you actually put this in a calculator, both times, no matter which one you use, you should get about 8.24. So if you reduce your fraction, you get the same answer. I don't think your textbook talks about that, but it is something good to note. Alrighty. 4.5 is all about negative exponents and their reciprocals. Way back in chapter, I believe it was chapter 6, we talked about reciprocals when it came to slopes. This is where it comes in again because use it again. So it's not new information, it's just a new way we've used it. Basically, if you have 4 to the power of negative 2, it does not equal negative 16, or 16 for that matter. Okay? It's not just as simple as assuming the negative makes your thing negative. So, we do have a couple rules here. And again, this kind of deals with our x to the power of m over n. When x is a non-zero number, basically any number but 0, why can't it be 0? Well,
Exponent can't be 0?
the x can never be 0. We'll get to that in a little bit, because you can never divide by 0, and when you're dealing with negative exponents, you'll be flipping stuff around and dividing. So, x cannot be 0. It can be any number. And n is a natural number. So again, no decimals. Make life easy. When this occurs, x to the power of negative n is the reciprocal of x to the power of n. So, if we think back to chapter 6, we talked about reciprocals. What do you do with a reciprocal in a fraction? Is a nice way of not telling me much. Can you explain that a bit better using mathematical words? What's happening? What are you doing? Yeah, you're basically swapping your numerator and denominator. So when you take the reciprocal, you flip or you swap the denominator and the numerator. So if we had 2 over 3, that would then turn into 3 over 2. Okay. If you had 3, what would 3 turn into? Adele.
-3.
Nope. Try again. Someone else.
1 over 3?
1 over 3. Because any whole number basically is over top of 1. So if you had the opposite, if we had 1/4, we took the reciprocal of that, what would it turn into? 4. Good. The reason why x can never be 0 is because if we have, well, 0 over 2 or 0 and anything, and you start to flip it, you're then dividing by 0, which breaks math. So we cannot ever do that. So x can never be 0. It can be anything else, can't be 0. So when it comes to our exponents, if you ever have a negative exponent, you have to deal with the negative exponent first. It takes precedence over everything else. It is the first thing you deal with. I'm going to flip the page around a room. So when dealing with it first, 2 to the power of -3. We must deal with the negative reciprocal first, or rather the negative exponent first. And then we deal with it is to get rid of our negative, we take the reciprocal of our x, or the number we're dealing with. So it is a lot of information. What is the reciprocal of 2?
Negative.
No.
2 over 1.
No. 1 over 2. There you go.
Third time.
It's 1 over 2. And the whole thing now becomes to the power of 3. We've gotten rid of that negative. So you get rid of your negative exponent, you take the reciprocal of whatever it is the exponent of. Then we just solve normally. Bless you. Because this exponent is to both, This is called quotient law. We'll talk about this tomorrow. We basically go 1 to the power of 3 over 2 to the power of 3. 1 cubed is 1. And what's 2 cubed? 8.
Wait, no.
2 times 2 times 2.
That is the
That's the answer. But this time we're going to use a fraction underneath. So if we have 2 over 3 to the power of negative 2. The first thing you're going to do is deal with your negative. So what is the reciprocal of 2 over 3? 3 over 2. As soon as you deal with that, you basically get rid of your negative of the exponent. We now have 3 over 2 to the power of 2, which, like last time, we distribute that exponent to 3 squared over 2 squared. 3 squared would be 9, and 2 squared would be 4. We can deal with decimals. And for right now, when it comes to decimals, at least for grade 10, I usually say punch it in your calculator. Because most of the time, especially for the test, I'm not going to give you guys a decimal just yet. But if you did punch like 0.2, 0.2 in your calculator to the power of negative 5, you should get a very large number.
Here, let me see.
What do you get?
0.2 to the power of negative 5.
Yeah.
3,125.
Yeah.
It doesn't make sense. It's pretty big.
So, 3,125. Which is odd. Until you start doing the math for it and realize, what's 0.2 as a fraction? Out of $1, if you had 20 cents, what is that as a fraction? It'd be 1 over 5, right? So if we had 1 over 5 to the power of negative 5, your first step is to take the negative reciprocal, so that would now become 5 over 1 to the power of 5. And what's 5 to the power of 5? It's not just probably, it is 3,125. And 5 to the power of 1 is still 1. So this shows up once in a while. Okay. So far, this stuff hasn't been that difficult. We haven't really thrown anything very challenging at you guys. Just simple. We just threw a negative in there. Now as we make it a little bit trickier, and we use the stuff we just learned from our last section to make it slightly more difficult. I'm hearing yay. I agree. Yay. So, 27 to the power of negative 2/3. Before we do anything else, I want you guys to try this by yourselves. Try it and see. Use the knowledge you've got. You should technically be able to do this. Give it a shot. So, we have to deal with our negative first. And the most common mistake we tend to see is people say, 27 to the power of 3 over 2. And they take the reciprocal of your exponent. That is not what you want to do. That will completely mess up your answer. We take your exponent, we take the reciprocal, we take the reciprocal of 27. What's the reciprocal of 27? 1 over 27. So, it is now to the power of 2/3. Based on yesterday's lesson, when we distribute this out, we go 1 to the power of 2 over 3 over 27 to the power of 2 over 3. We then go boots and hats, the nook, whatever you guys want to do, to realize we take the root of 1. It is the cubic root of 1 squared divided by the cubic root of 27 squared. Cubic root of 1 is 1. 1 squared is 1. The cubic root of 27, what is that? What is it? 3. Okay, I heard 33. 3 squared is what? 9. It's not too bad. That's about as hard as I can make it. I can give you guys one step more,
No.
but really, that's all we're doing. So we'll do one last question, and then I'll let you guys... Yeah, we'll stop there. Give you guys homework after that. So, 9 over 16...
Yes.
There'll be homework. No, 9 over 16 to the power of negative 3 over 2. Try that, please. As we approach this, first things first, this negative, take care of it. We do that by taking the reciprocal. So we have 16 over 9 to the power of 3 over 2. Right, Aiden? Yes. So, good. So, when we do this, we distribute 3 over 2. So we have 16 to the power of 3 over 2 over 9 to the power of 3 over 2. We turn this into a root. So we have the square root of 16 cubed divided by the square root of 9 cubed. The square root of 16 is 4. It's cubed. And the square root of 9 is 3 cubed. What is 4 to the power of 3? 64. And what is 3 to the power of 3? 27. Beauty. Your homework is on page 233. Questions 6 to 10 and 13. And I want you to do all the letters.
So you just
Do all of it. Cool? Cool. You probably have about half an hour. This should be easily done in that time.